Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about nested loops. Okay, so let's see what they are. They are really simply just a loop within another loop. So for example, let's do a for loop for int I equals 0, let's say less than 3, I plus plus, so a regular for loop. And then inside it, we can write another for loop. Let's say int j equals 0, j less than 2, j plus plus. And by the way, usually the convention for these iterator variables, usually use the variable I, then you use j, then if you need more, you need k, l, m, n, and so on. That's usually the standard convention, but it's not a requirement, it's really just a convention. So these can be named whatever you want, but in general, I and j are very commonly used. So over here, let's do this. Let's do a loop inside another loop. And now let's print out the I and j to see exactly how this code is running. So let's print out I, then a little comma, and then j. Okay, let's see. And if there it is, so we start off with an I of 0 and a j of 0. And then we have an I of still 0, but then a j of 1, meaning that for each time this loop is running, this one is going to run as many times as this loop is meant to run. So it goes inside this, runs this line. Then when this one ends, goes back into this for loop and runs this line again. Then this one reaches the end, so that is why this one ends and again goes back into this one, which again runs this loop starting from the beginning and runs more and more and so on. So here it is running 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and 2, 1. The important thing to remember here is the code execution order, meaning for every time the outer loop runs, the inner loop is going to run multiple times, 2 times in this case. Also remember what we covered in the basic section about variable scope. If you define some kind of variable inside this inner loop, like a int age equals 5, if we do this, and down here you try to access the age, nope, that does not work. If you define something inside the scope of this inner loop, it does not exist outside of it. And here we have one nested loop, but technically we can have as many as we want. Again, the same logic. For every time that this loop runs, any loop inside of it will run as many times as those run. As you can imagine, if you do a ton of loops within other loops, if you do that, it becomes really hard to understand the logic the deeper you go. So usually just having one nested loop, in most cases that is the most you should do. Then we already saw these briefly being used in the last lecture covering multidimensional arrays. That's a very common use case. So here it is, that same code. So we've got the outer loop going through the first dimension, and then we got the second inner loop. That one is going through the second dimension. And by doing this, this is going to cycle through every element inside of this multidimensional array. Then on loops, there are 2 important keywords. One is called break, and this one breaks out of the innermost loop. So for example, if we don't include the break, let's see how many times this prints with the value on j. And if there you go, the value on j goes from 0 to 1, 0, 1, and so on. But if we add a break over here, and if there it is, now the j only goes to 0 and immediately breaks out of that inner loop. Now the important thing to note here about break is how it only applies to the innermost loop. So this one does not break out of the outer loop. As you can see, the outer loop still runs 0, 1, 2, and so on. So break only affects the innermost loop. If you do want to break out of the outermost loop, if so, you can define some kind of bool, break from loop. You set it to something like false. Then inside this one, you do some kind of logic that would eventually set this one to true. And then down here, you would test that. And if so, then call break. And let's see. And yep, now this one does go inside. As soon as it goes inside, sets that break to true and breaks from that one. So breaks from the inner loop, and once this one is true, it also breaks from the outer loop. Now the other important keyword is continue. This one continues or pretty much skips to the next iteration of the loop. So if we write some kind of code after this continue, so let's do a right line and write something like this. Even Visual Studio is telling us, so this line is slightly faded because it will never run, so unreachable code detected. That is because as soon as the code gets to this continue, it is going to ignore everything afterwards inside this loop and go to the next iteration of this loop. So if we run this, and if there it is, it runs through every single element, so the j is always 0, 1, 0, 1, and so on. But note how our second message, this one did not ever show up. If we were to put this inside some kind of if, let's say if I equals 0, then continue. So basically on the first I, when the I is 0, then it should not print this message, but on the other ones it should. And if there it is, so whilst on 0, it is going to continue and ignore this line, but on the others, it is going to run this line. And again, same thing as previously, note how this one only applies to the innermost loop. Even when we're running our continues over here on I of 0, note that the I still runs all of them, so 0, 1, 2. So again, always remember that break and continue, those only affect the innermost loop. Now I should also say that break and continue are not specific to just nested loops. You can use these keywords with any loop, including just a single regular for loop or some kind of for each. For example, if we have some kind of player class, so for example, here's some simple code. So we've got a basic player class, then we create a list of type player, then we create a new special player, we add that special player onto the list, and then 3 random players. Then we do a for each inside of that player list, cycling through every single one of them. and then we check if that one is a special player. If so, let's continue. If not, let's write in the name. So if you do this, we should be able to see the print of only 3 players and not the special player, because that one will be skipped over here on the continue. And if there you go, exactly that, 3 players and no special player. Now also on the topic of nested loops, here we have a 4 inside another 4, but you can list any loop of any type. So for example, over here we can have a 4 inside another 4, and then inside both these 4s we've got our 4 each, so this perfectly works. Or we could replace this with a while or a do while, so literally anything works. So as you can see, nested loops can be really useful, especially when cycling through multidimensional arrays. But if you go too deep, if you nest too much, it can negatively affect code readability. If that's the case, consider whether you really need to make that nested loop, and if so, perhaps consider making a function that in itself has a loop. Then within some kind of outer loop, you just call that function. So just be aware that nested loops can become messy very quickly, so do be careful to use them properly and only when needed. Okay, now that we've learned some more advanced use cases for loops, we are ready to learn something that some people find quite complex, which is recursion, so let's learn that in the next lecture.